brief synopsis of the S6 equation solving techniques. You have this equation, you got a denominator here, you got a denominator here. You multiply both sides by the common denominator and you get an equation that looks like this. You simplify it, you find that it's quadratic, as you can see, because you have x squared, x's, and constant numbers. You put it into the standard form of a quadratic, and then you use either the quadratic formula or factoring to solve it. If you use factoring, you use the zero property, which is illustrated in a little more complex situation here. Zero property is simple. If the product of three things is zero, then one of those things has to be zero, at least one. And also, if at least one of those things is zero, the product has to be zero. In order to do this, we consider x squared minus 4x, x squared plus 5x minus 6, set it equal to 0, solve it by factoring. We find that it's 0 when x is negative 6 or 1. X minus 2 is 0. Well, that's very clear. That happens when x equals 2. We spot that right away. And quadratic here, we test this to see if it's 0. We set it equal to 0. The discriminant's negative, so it has no real solution. And if we're trying to graph the, trying to solve the equation over real numbers, then there's no real solution that comes out of this. And the only real number solutions we have are these. Now, if we do the complex solutions, we get complex conjugate solutions in this case, and those would also be zeros of the equation, although they wouldn't show up on a y versus x graph. Got an even power of the variable, x squared equals 7/3, for example. Well, x equals the square root of 7/3. You take the 1/2 power of both sides with the square root of both sides, you get a solution, but that's not the only solution, because if x is equal to the negative of that, its square is still going to be 7/3, since squaring obliterates negative signs. So there are two solutions, and you've got to be very careful about that. Some people haven't been as careful about as they might. If you had x to the 4th equals 7.3, same thing. X could be the 4th root of 7.3 or 7.3 to the 1/4. X could be negative 7.3 to the 1/4 because this is an even power. Okay, every other power is going to change that negative sign to a positive. So it's negative, you take the second power, it's positive. Third power is negative, fourth power is positive. So that both of these have to be solutions. If this was an odd power, then you would only have the positive solution, but of course you could have an odd power equal to negative, in which case you'd have a negative solution, and hopefully you've got that sorted out. Absolute value equation, if the absolute value of something equals 3, then either that something has to equal 3 or that something has to equal negative 3. Could be either. So we say that the contents of the expression inside the absolute value sign could be 3, the contents could be negative 3. This gives us two equations that we easily solve. We have mixed types of equations. I chose one that doesn't have a solution, but I just wrote one down. You have a power function and an exponential, okay? And that's a mixed type. Now, we've already seen if you have an exponential equation, if this was equal to, say, 8, we'd be able to solve it, divide both sides by 12, and change it to logarithmic form, and so forth. And we might be tempted to change this to logarithmic form. That would get the x out of the numerator where you can operate, out of the exponent where you can operate on it. But you would end up with a log of x over here. So you'd have a log of x equal to a multiple of x. It's hopeless. Okay, and most times when you have mixed types, like an exponential with a power function, a quadratic with a power function, unless the power function happens to be 0, 1, or 2 power, a logarithmic with an exponential, you're not going to be able to solve it. In that case, you can always graph this side and this side. Now, I've simplified the equation slightly. I divide through by the 3. Then I only have to graph x to the 5/8 and 4x, 4 times 1.4 to the 5x. X to the 5/8 has a graph that looks like this. It goes through 1, 1, and it looks a whole lot like the square root of x. It's, it's a little different, okay? Not quite as curvy It doesn't have quite as much curvature. The graph of 1.4 to the 5x might look something like this. I went through the details. And 4 times 1.4 to the 5x will look like this. The only place these graphs can be compared is on this side of the y-axis where this function is defined, and on this side of the x-axis, this graph and this graph never meet, so you don't have a solution. There's no x value for which this y value is equal to the y value you get for this function. In other words, there's no solution to this equation, and therefore no solution to this equation, because these two equations are equivalent.